Here's the example project for Web API. Notice that we have three projects in the solution. A front-end Blazor WebAssembly application, the Web API project, and a class library that shares the product class between the two. The exact same repository types we used earlier are now on the Web API side. In Program.cs, we just add controller support to the dependency injection container as opposed to controllers with views in MVC. And at the end, we map the controllers, but this time without a routing table. So how does Web API know how to map URLs to controller actions? We'll see that in a minute. I want to point out two other things in Program.cs. First of all, support for Swagger is added. Swagger is another word for OpenAPI, a standard that describes a REST API. We also add support for a UI around that. With a UI in place, we can open a browser and navigate to the /Swagger URL. Swagger acts as documentation for this API. We can see which endpoints this API has available. Switching back to Program.cs, there's also support for CORS added. Requests done by applications that run in the browser outside the domain used by the front-end application are not possible, unless explicitly allowed. With CORS, I can allow our Blazor WebAssembly application explicitly. Here's the heart of the API, the controller. It is a class that derives from controller base, which is basically a controller without view support. It is decorated by the API controller attribute. This attribute enables API features on the controller. One of the things it does is require attribute routing instead of a routing table. We now specify the base route for the controller like this. Controller here is an expression that will evaluate to the name of the controller without the controller suffix. So in this case, product. The controller has an action called getAll, which returns an action result. This time we use action results that convey an HTTP status code in response so callers can see what the result of their request was. When there are no products, we return no content, that is HTTP status code 204 for example. And when everything was successful, we return OK, status code 200, with the list of products. Serialization of the products object is automatic. The getAll action is configured to respond to a GET request. So this means that when a GET request is done to /product, this action will execute. The name of the method isn't relevant to the caller of the API. Get1 also responds to a GET request, but it has extra routing information. It is configured to expect an ID in the URL that should be an integer. If there is a match to this route, the action will fire and the ID parameter will automatically get its value from the URL. We get the product from the repository using the ID. If there's no such product, we return HTTP status code 404, not found. If there is, we return OK with the product again. To test things out, I'm opening a browser. When I go to the /product URL, you can see the JSON coming back for all products. When I go to /product/1, I just get the product with ID 1. And when I type a string instead of an integer, the URL can't be matched, resulting in a 404. There is one more action in the controller, the one that reacts to a post. It takes a product as a parameter. Again, data binding, taking the data from the request and deserializing it into a product, is automatic. We can also do validation using model state, returning an HTTP status code 400, bad request, when the product doesn't pass validation. But because we decorated the controller with API attribute, this code actually isn't needed because it is done automatically by Web API. So the only thing we have to do is add the product to the repository and return a status code 201 created. With the created@action action result, we can include the URL to the newly created product in the response. Okay, now that we have a fully functional API, it's time to consume it from a front-end application. I've changed the program CS of the Blazor WebAssembly application a bit. An HTTP client is added to the dependency injection container. HTTP client is the class to use to do HTTP requests. It is configured to send the requests to the API. Now that the repository class is moved to the API, I have introduced a product API service class that is responsible for doing the actual requests. Let's take a look. It gets the HTTP client injected. In getAll, it uses it to do a GET request to the product URL. And the next line ensures an HTTP status code in the 200 range, which indicates success. If another status code is returned, an exception is thrown here. After that, the data contained in the response is read and deserialized into an IEnumerable of product, which is returned from the method. The add method gets a product as a parameter that is wrapped in a JSON content object. This object can then be used to do a POST request to the product URL. The payload of the request will be the product serialized to JSON. Often, things like the ID of the product are added by the API. It's important for the caller to get this info. That's why the response will contain the product as it was added to the data store, which we can deserialize and return. The code in our index and create page hasn't changed at all, except for the fact that we now get the product API service injected instead of the product repository, calling the relevant methods on that. Next to the controller pattern, there's another way to do Web API. You'll see that next. Here's a project that uses Web API with a minimal API pattern instead of the controller pattern. Instead of adding controllers in the program CS, we now call Add Endpoints API Explorer. This gives us the ability to specify endpoints directly in the pipeline by using the map_get method on the app object. The first parameter is the endpoint name where the URL will map on. The second parameter is a delegate type for which we have to specify a function. As a parameter, product repository is taken, which will be automatically injected. We still return action result objects, which are now contained in the results static class. The second map_get has the ID parameter again, which is mapped to the first parameter of the function. And there's also a map_post to facilitate a post request. One thing to keep in mind is that we don't have all the built-in goodness of a controller using minimal APIs. Validation, for example, is not automatic, so we have to write our own code to do the actual validation. The post uses the created@route action result instead of created@action, pointing to the name of an endpoint. Other than missing some controller functionality, this API works exactly like the one with controllers I showed you. I didn't change a letter of code in the front-end application. I'll talk about gRPC APIs next. With gRPC in ASP.NET Core, we can build APIs that are different than REST APIs. Just like REST, gRPC is a standard that is also used outside of ASP.NET Core. Therefore, it's possible to create a gRPC API using ASP.NET Core and use a non.NET client, or the other way around. Instead of relying on the HTTP protocol methods such as GET and POST, gRPC works by using remote procedure call. That's where the letters RPC stand for. It's convenient to think of the word procedure here as another word for method. So, It means calling a method from a remote location. It uses the HTTP 2 or 3 protocol and a very efficient binary serialization format called protocol buffers instead of JSON. A contract is used to describe what methods the API has and what the parameters and return types are. Here's the contract for the carved rock application. It is contained in a proto file. After some metadata, a service is declared. In the service, there is a method declared called getAll, and it takes an AllProducts request as a parameter and it returns an AllProducts response. CreateNew uses the same pattern, which is a best practice when using gRPC. The next lines describe the shape of these types. AllProducts request contains nothing. The sole reason we have it is to conform to the best practice. AllProducts response contains a repeated product property, which translates to a list or IEnumerable of product in .NET. CreateNew request and CreateNew response just contain a singular product property. And finally, the product type is defined, containing 5 simple types that are built into the gRPC standard. You've probably already noticed the equal sign with a number after the property declarations. These are all about the efficiency of gRPC. Because there's now a contract that gives numbers to properties, there's no need to repeat the property names in the serialized data over and over again. The contract, the proto file, is shared between the actual API and the application that uses it, called the client here. Both have tooling that can take the proto file and generate code from it. On the server, this results in a generated base class with virtual methods, enabling us developers to write the implementation for it. On the client, a client class is generated, on which we can call the method directly. That class will then take care of calling the remote method on the server. Requests and responses are serialized using protocol buffers. Now let's take a look at an implementation.